my name is Maraham Hamid and welcome to this session. Today I'll be explaining an introduction to computers, programs, and Java. So what is a computer? Specifically the components of it in a hardware. So the hardware is the physical things of a computer. Basically, there is a CPU, memory, hard disk, floppy disk, monitor, printer, and communication devices in a computer. So all these components are connected through one thing, which is called a bus. So they are running through it. The CPU, or the acronym of the Central Processing Unit, is the brain of a computer. So it gives the commands and instructions to the memory and storage device that saves the data. So it's a component of a computer that is externally fixated in it, and its speed is measured by megahertz. Memory is to store data and program instructions for the CPU to execute, and the data type that is used for a memory is a byte, and 1 byte is equal to 8 bits. So what is the bit? A bit is 0 and 1, and it's the language that the computer does comprehend and understand. How is the data stored? There are various kind of data that is stored into computer. For example, numbers, characters, and strings, and they are stored into computer by or as bits, which is 0 and 1. 0 means off and 1 means on. For example, us as a human, we might understand a specific language, for example. How is data stored? There are different types of data in a computer, such as numbers, characters, and strings, and all these are encoded in a computer using zeros and ones. 0 represents off and ones represents on. So the computer comprehends only 0 and ones because it's a digital device and it has only two stable states that it can understand. Let's talk now about storage devices. It is a short-term memory. So when we want, for example, to have a Word document on our laptop, if we didn't save it and shut down our computer, we will probably lose that data. So the storage device is a temporary data. As long as your computer is turned on, it will work perfectly fine, and when it's off, all that data will be vanished. So it is permanently stored only. And there are three main storage devices, which are disks, CDs, and tapes. Now let's talk about the output devices in the monitor. So we do connect it to the computer using an output, and all the information is connected through the laptop using an input device. Let's talk now about the monitor resolution and dot pitch. What is a resolution? The resolution is the number of pixels in the horizontal and vertical dimension of the display device. So what is a pixel? It is the distance that is not the same between these blocks in a computer. So how we can actually see these colors in our computer and this image, how we can see it? It's because there are a number of pixels on your screen, and the closer these pixels are to each other, the clearer the image is. And this space between each pixel and the other is called the dot pitch. The closer they are, the clearer the screen is, or the image is. Lastly, let's talk about communication devices. So, a communication device basically is like Wi-Fi, Bluetooth, Ethernet, cables, modems, and NIC. So it is the devices that transfers the data. Now let's talk about digital computers. There are three things that are inside the CPU, which is the control unit, the ALU, and registers. The ALU makes the ALU in a computer makes the calculations, but it is not the memory. It doesn't save any information, it only processes it. While registers are using the control unit that will give the instructions. Now let's talk more about data representation. So how does the computer represent data? Of course, that would be by saving it. So by using the binary language, which is zeros and ones, inside one bit, I can program inside it two decimal points only. For example, 2 to the power of 4 is equal to 16. 2 here is the bit, and 4 is the number of data that will be stored inside this computer. How is a letter converted to binary language and back? For example, if I wanted to print the letter capital D on my laptop, what would I do? First of all, we have our keyboard. This keyboard has sensors in it. So, the sensor in the keyboard, when I click a certain letter, will be interpreted to the computer. So, in my case, I'll be clicking Shift plus D key. While using the sensors, the electronic signals for the capital T is sent to the system unit. Next, in the third step, when it's presented on the screen, it will be taken from the memory and converted into an image to be displayed. It will display using black colored pixels on your screen. Now let's talk more into depth about programs. They are actually the software. So previously we've talked about the hardware, which is the physical things you can touch in a computer. It's the opposite of a software, which is the instructions that is given to the computer, the stuff you program inside the computer. So you can tell the computer what to do through programs. And these programs are written using a programming language. For example, we have Python, C++, C Sharp, Java, and the list goes on. There are many programming languages that can interpret your programs to the computer. Due to that, there are also different programming languages, which is the machine language, the assembly language, and the high-level language. The machine language is used for the computer to understand the binary language, and it's highly difficult to read and understand. So the machine language is basically the zeros and ones, which is on and off. And obviously humans can't read zeros and ones, so we need to be writing our own programs that then is translated to the machine language. And that's the job of an assembler in the assembly language. It has few defined words in English, for example, 3 to 5 words, and then an assembler is used to translate it back to the machine language. So we do define in our assembler this 2, 3 words, and then using the assembly language, and then using an assembler, it will translate it to the machine language so the computer can actually understand it. Finally, let's talk about the high-level language, which is actually English-like and very easy to learn. You can write whatever you want and translate it to the machine language. It's very easy and like English. And here are some popular high-level languages. For example, we have ADA, Basics, C, C++, C Sharp, and the list goes on. Now let's talk about interpreters and compilers. Previously, we've mentioned that in an assembly language, we use an assembler that can translate it back to a machine language. But what can translate the high-level language back to machine language? That's the job of an interpreter and a compiler. So there is a slight difference between the interpreter and compiler, but they both do the same job. In an interpreter, it does translate your code line per line, while a compiler takes your whole code and then translates it at once. So its advantage over an interpreter is that when you make a program, you need to keep executing the code. But when you use a compiler, you can from the beginning execute it directly without any translation. So it saves more time and it is widely used in other platforms. Now let's talk about operating systems. In the same hardware, we have different uses of it, and it has different communication in the user interface. For example, we have 3 different famous operating systems, which is macOS, Windows, and Linux. Linux actually is the best because you can make a parallel implementation and execution in real time. Then Windows takes the second place, and finally macOS. macOS actually doesn't really have an open access. So, why we're learning Java? What is the purpose of learning this programming language? Java is a commonly used language, especially for internet applications, apps, designing, and etc. It is a general purpose language as well. So applications help from browsers and hand devices develop application and for application development from web services. And it's a general purpose programming language. You can use it for many other purposes as well. If you'd like to learn more about Java's history, please have an access to this link and read more. Let's talk about the characteristics of Java. Java is simple. So, Java was actually particularly modeled on C++, but greatly simplified and improved. So, there is more functionality and less negativities. Java is object oriented, so everything is indicated around objects. It does focus on necessary aspects to focus on specific solutions. Java is distributed. You can distribute the workload through different processors. So Java writing network programs is like sending and receiving data to and from a file. Java is interpreted. So after writing the program, you can compile it and implement it. So compiling it means translating it and implementing it, it means that you can have it anywhere. Java is robust. So it detects errors before running the code. Java is secure. So Java has a very good protection system against viruses, considering that the applications has internet access. Java is agriculture neutral, so you can write the code once and run it anywhere on any other device. Java is portable. You can run any program without having it recompiled. Java's performance. It doesn't need to be recompiled, so there is a better performance. Java is multi-thread. What is a thread? A thread is lines of code. So you can mix many functions and send jobs at the same time. Java is dynamic. You don't need to revise the whole code. You only need to add the new lines of code. Now let's talk about a JDK. What is a JDK? J represents to Java, D represents to development, and K represents kit. So JDK is a Java development kit. A JDK is a tool used to develop applications in Java, and there are different versions of it because it's updated by time. And there is also an SDK, which is a software development kit that has a similar purpose to a JDK. Let's talk about an IDE. An IDE is used to build platforms in Java, so we write the codes in it. An IDE like NetBeans, Eclipse, IntelliJ IDEA, they are all platforms that you use so you can write your lines of code in. And you can't install an IDE without having a JDK. So you need to first install a JDK on your laptop and then install an IDE so you can have your IDE actually working. Now let's try doing a simple Java program. Alright, let's do some programming. First of all, we need to know some of the basics. In every program, we need to have a class and we need to have a method. So, a class is in here, it's in the beginning of a program. In every program, we need to have at least one class. And that class needs to be named with an appropriate name. In this case, our class name is main. Anyways, and here we have our method. And both has brackets, so they can contain a program. Now, let's print our statement. So, for example, if we want to print anything in Java, we need to have this format, which says system.out.println, and between two quotation marks, we're going to have what we want to be printed. For example, let's print hello world. After printing hello world, we're going to have here a semicolon, and after every single statement in our program, we need to have a semicolon. And it is called a statement terminator. Here this code acts or is called a statement. Let's learn more about these special symbols in Java. This is called a bracket. So it is the opening and closing of something, and it does contain some stuff inside it. It denotes a block to enclose statements. Next, let's learn more about parentheses. So they do also the same job in a different way. Next is also these opening and closing brackets. It's used in arrays to be specific, and we're going to have it in our last chapter. Now let's learn more about double slashes, or how to write a comment. Sometimes we need to write a comment or we won't remember something in our program. So we have to write a double slash and then, for example, write this is the format of how to print anything in Java. So these comments are for us to refer back to later, or for example, if there is another programmer that is going to continue this code, they might need some background knowledge so they can read these comments. Here we have the double quotations, which is enclosing a string or sequence of characters. Finally, a semicolon indicates the end of a statement. Always have appropriate comments, naming conventions, and proper indentation and space lines. A comment can be extremely sufficient when you want to remember the data again. Let's talk now about indentation and spacing. So, here, for example, in this code, in our class code, we can see this bracket here is enclosed here. So this is called indentation, which is the space of where something is placed. So here there is no space, here is a space, and here is a space. And each space expresses a sequence that this is inside of that, and that is inside of this. And this is containing everything. Sometimes as well you need to have a space. For example, after your method, sometimes you need to add a space. And the purpose of it is just to have your program well organized and to separate, for example, data. For example, if this comment wasn't relevant to your printing statement, then you might want to add a space just for organization, but considering that they are relevant to each other, we can keep them together. Finally, let's talk about block styles. Sometimes some people like to have these brackets just next to the main, and some likes to have it in a new line. Both works perfectly fine, and both has the same job, but it is also based on personal preference. Let's talk about programming errors. There are three different types of programming errors. First is the syntax error. A syntax error is more like a grammar error that can be detected by the compiler, so your code will not be running or compiled without having these errors fixed. As you can see here, the quotation marks are open, but not closed on the other side. So this is a syntax error, which is more like a grammatical error. Now let's talk about runtime errors. These types of errors causes the program to abrupt. So the program will be running, but it will suddenly stop and abrupt. For example, when you have some infinity codes. Finally is the logic error, which is when the program runs, but the output is false. And that is actually the hardest type of error because it's very hard to detect. That is for today. Thank you for watching and see you next time.